and welcome to GCSE Maths Help. Today we're going to be looking at compound measures and the key points you need to know for your exam. Let's get started. Compound measures are calculations that involve two or more variables. For example, speed equals distance divided by time, pressure equals force divided by area, and density equals mass divided by volume. These questions are always real-life scenarios. For example, Priya and Joe travel the same 16.8 kilometre route. Priya starts at 9 o'clock and walks at a constant speed of 6 kilometres per hour. Joe starts at 9:30 and runs at a constant speed. Joe overtakes Priya at 10:20. What time does Joe finish the route? So let's start with our speed equation. So we've got speed equals distance divided by time. So when Joe overtakes Priya, they've walked the same distance at that point. So Priya has been travelling at 6 kilometres an hour, which is equal to the distance divided by the time, which is 1:20. So that's 1.333 hours. So that means that the distance that Priya has walked is 8 kilometres. So if Joe travelled that same distance, he's done 8 kilometres, but he did it in 50 minutes, which is 0.8 hours. His speed must be 9.6 kilometres an hour. So the question says that he runs at a constant speed. So if he's going at 9.6 kilometres an hour, we can use that speed to see how long it takes him to do the full 16.8 kilometres. So he's travelling at 9.6 kilometres an hour, but the distance this time is 16.8 kilometres. So we can work out what the time is. So if we rearrange our formula, times both sides by x and then divide by the 9.6 kilometres an hour, that means that x is equal to 16.8 kilometres divided by 9.6 kilometres an hour. So x is equal to 1.75 hours, which is 1 hour and 3/4. So the question asks, what time does Joe finish the route? He started at 9:30 and we want to add 1 hour and 3/4. So that means he finished the race at 11:15. Whenever you're doing any of these compound measures questions, you need to be really careful what units you're working in. Priya's speed had been given to us in kilometres per hour, so we needed to change the minutes that we were looking at into hours so that we could put it into these equations. So just be really careful when you're doing these kind of questions. You need to be able to interpret graphs that represent these compound measures. For example, on a time-distance graph, when the line is climbing up, the distance travelled in the time will equal the speed. If the line is flat, then there's no distance being travelled, so they must be stationary. For example, Lily goes on a car journey. For the first 30 minutes, her average speed is 40 miles per hour. Then she stops for 15 minutes. She then completes the journey at an average speed of 60 miles per hour. The total journey time is 1 hour. Draw a time distance graph for her journey. So for the first part of her journey, she travels at 40 miles per hour for 30 minutes. So she must have done 20 miles. So we'll put a dot just there. For the next part of her journey, she stops for 15 minutes. So there's no distance travelled, so that line will be flat, so we'll put another dot there. So the last part of her journey, she travels at an average speed of 60 miles per hour, but the total journey time is 1 hour, and we've already accounted for 45 minutes, so the last part of her journey must be for 15 minutes. So travelling for 15 minutes at 60 miles an hour, she must have covered 15 miles. So at 60, we'll put her at 35 miles. So now we can join the dots. We'll join this up here. The next bit is flat because she didn't travel any distance, and then we're going up there. So part B says, write down the average speed for the total journey. So in the first 30 minutes, she did 20 miles. For the next 15 minutes, she did no miles at all. And in the last 15 minutes, she did 15 miles. So our speed equation is speed equals distance divided by time. So Lily's done 35 miles in 1 hour, so the average speed for our whole journey is 35 miles per hour. When looking at a graph with speed on the y-axis and time on the x-axis, you can calculate the distance travelled by working out the area under the line. This can be done by splitting up the area into shapes, and then you can find the area of the triangles, the rectangles or the trapeziums and add them all together. Some questions will ask you about calculating the rate of interest or depreciation. This could be how much a bank balance will grow after 5 years of interest, or how much value a car loses after being used for 3 years. You can do the calculation by working out how much the value changes each year, working it out year by year if you want to, or you can use this handy formula. So when the amount is going to increase, you take your starting amount and times it by 1 plus the rate divided by 100, all in brackets, to the power of the time scale that you're looking at. If the amount's going to decrease, you do the starting amount times 1 minus the rate divided by 100 in brackets to the power the time scale that you're looking at. The amount is your starting number, your rate is your percentage change, and your time is the years taken. For example, Mirrick invests £6,000 at a compound interest rate of 1.5% per year. He wants to earn more than £1,000 interest. Work out the least amount of time in whole years that this will take. So let's start with our formula. We've got amount times 1 plus the rate divided by 100 to the power the time scale. So it's going to be plus the rate divided by 100 because we want the money to grow. So we're starting with £6,000 times 1 plus 1.5 divided by 100, and then it's the time scale that we don't know. So it's going to be really difficult to find a value for x by rearranging the formula and whatnot. So we're going to use a method called trial and error. So we're going to pick a few values for x, put them into our formula and work out at what point he's made £1,000 interest. So we want the money to be up to £7,000. So let's start with x equals 5. If we put that into our calculators, the money is up to £6,463.70. Let's try x is equal to 8. That gives us £6,758.96. So we're getting closer. Let's try x is equal to 10. So that gives us £6,963.24. So we're nearly there. Then x equals 11 gives us £7,067.63. So we've made £1,000 interest at this point, so it's going to take him 11 years to make the money that he wants to. The last thing we need to cover in this topic is when these compound measures are proportional to each other. When two things are directly proportional to each other, as one value increases, the other value increases at the same rate. We describe this as y equals k times x, where k is a constant number that x is always times by. When two things are inversely proportional to each other, the opposite happens. When one value grows, the other decreases. This is written as y equals k divided by x, where k is a constant number. Questions will often require you to work out what number k is in the equation. For example, a ball dropped vertically falls d metres in t seconds. D is directly proportional to the square of t. The ball drops 45 metres in the first 3 seconds. How far does the ball drop in the next 7 seconds? So we've been told that d is directly proportional to the square of t. So our formula is going to be d is equal to k times t squared. So to find out what k is, we're going to put in the values that we've been given. We've got 45 is equal to k and then 3 squared. So 45 is equal to 9k, so k is equal to 5. So to work out how far the ball dropped in the next 7 seconds, we need to work out how far it dropped in 10 seconds and then take away the first 3 seconds that we've been given. So if we put distance is equal to 5, because we know what k is now, and then times 10 squared, the distance after 10 seconds is 500 metres. So we can do 500 metres, take away the 45 metres that it fell in the first 3 seconds to give us 455 metres. I really hope you found this video helpful. If you'd like to have some practice at answering exam-style questions on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.